is done. So we will move on to question number 9, which will be very straightforward and easy things based on the industrial chemistry and environmental. Okay. So this process is asked about nitric acid, the Oswald process. So we have already discussed this thing before in 2014 and 12. So we have seen this industrial process before. So state the raw materials used. So normally we use ammonia and air. That is another one. Okay. Air is because of we need oxygen here to react with this one, and also we need water, H2O. Okay. So write the balanced chemical equation with appropriate condition for the reactions taking place in this process. Okay, so I will use the board to write down the reactions. Okay, so what are the reactions? The first thing is in the process formation of NO. So then NO react with O2 to form NO2, and finally NO2 with water, which will produce HNO3 and HNO2, or either with oxygen instead of NO2 plus water directly. We can add also oxygen, NO2 plus water plus oxygen. It will give directly HNO3. Okay. So the reactions are this. So 4 ammonia gas with 5 O2 gas will give you 4 NO plus 6 H2O. Okay. The important part is the condition. So the pressure is around 1 to 9 atm, and the temperature is around 850 to 1250 degrees Celsius. And catalyst, you can use platinum catalyst directly, or either platinum with 10% rhodium. So this is what commonly used, platinum plus 10% rhodium, because it allows additional surfaces for the adsorption of ammonia and oxygen. Okay, and this is one of the first reactions. So this is what normally happens in the beginning. Then what you have to do is you have to allow this to cool down to room temperature. Okay, first you should allow it to drop the temperature, and then in around like 150 degrees you heat it up to 150 degrees Celsius along with cold air. That is very important to understand here, because when you have NO gas, O2 gas, which is typically called in the cold air, hot temperature with cold air in the system would be very essential for this particular reaction to happen, and this will provide you NO2 gas. This is step 2. And finally, this NO2 with oxygen and water will give HNO3 directly. Okay, so here there will be 4 HNO3, 2 water molecules, and 1 oxygen with 4 NO2. This is the complete equation. Okay, so this is what they have given in the evaluation also. So here also they have used cooling the gas, cooling the gas. But you can also use the other equation that we normally write. It was just NO2 plus H2O will give you HNO3 plus HNO2. Okay, so this equation also possible. Then you need to write HNO3 again, this same reaction. Okay, so there is a disadvantage of directly using water, only using water. Disadvantage is it will produce HNO2, which will also decompose again into NO. So you have to again remove this NO and again put into this step. So it is difficult. So it is always good to use oxygen, which is cold, which will directly produce HNO3. There is no HNO2 produced, so it will be an advantage. Okay. So this would be step 1, this would be step 2, and this would be step 3. Okay. So the next question asks, calculate the maximum amount of nitric acid that can be produced from 100 moles of diatomic gas. So diatomic gas means here, this is oxygen. So if you use 1000 moles of oxygen, they are asking how much amount of HNO3 can be produced using this method. Okay. So it is important to understand. So these are the main processes, right? So I will use the blue color one. I will stop the screen also. So we have to use 1000 moles of this oxygen, right? So think about the fact, if you have this ratio 5:4 NO is produced, 5 oxygen to 4 NO. So you can calculate the amount of NO that is going to produce from oxygen. And here, if you know the NO, you can find NO2. And if you know NO2, you can find HNO3. Okay. But we don't have to do all these calculation, because you need to understand, to make this 4, this equation can be multiplied by 2. So if you multiply this equation by 2, it will be 4NO plus 2O2 will be given 4NO2. And here you have 4NO2, here you have 4NO2. So the stoichiometry between these two are now same, and the stoichiometry between these two are now same. Which means directly you can compare the stoichiometry of oxygen to this one. Okay, because 5O2 will give 4NO, which is this one, and this 4NO will give 4NO2, which is this one, which means it gives 4HNO3. So finally we have a relationship 5O2 is to 4HNO3. So basically, if we use 1000 moles of this one, HNO3 moles will be 1000 over 5 to get 1 mole of oxygen and multiply it by 4. Okay. So basically, there will be how much? It's the it's the 200. Yeah, so basically 5 over 4, the ratio will be equal to 1000 over x. So 5x is equal to 4000 over 5. So it will be around 800. Okay. So using this equation, you can directly predict the amount of HNO3 that is formed. That is one of the advantage of using the entire equation. So this is what they have asked here. You can do this calculation. That is very simple. I don't have to tell that. And we have another question, give 3 uses of nitric acid. So remember, when we heard about this nitric acid uses, the main use of nitric acid in Sri Lanka is to produce the fertilizers. Okay, so that is the main use. And then we can use nitric acid even for making explosives, for an example TNT, and we can use for making gunpowder even, KNO3s, using this nitric acid. And also typical use is using the production of aqua regia. So aqua regia is a mixture of HNO3 and HCl. So you can use HNO3 to make aqua regia, but aqua regia is normally not used in Sri Lanka. Means not produced typically in Sri Lanka, because HNO3 is not coming here in a very, very pure form. You need very pure form to make aqua regia. Okay. And pure concentrated nitric acid is a colorless liquid. So you all know, we discussed about this nitric acid before. Normally when you have nitric acid, we see in a colorless state, but when this is exposed to light, it turns yellow. So they are asking, explain this observation. So basically what is happening here is, when you have HNO3, when you expose this into light, so it will give you NO2. Okay, it will give NO2 and then O2 and water. Okay, so this will give NO2, O2 and water. So you can balance this one, 2 here and 4 NO2, and here you can put 4 HNO3. So you know NO2, the color of NO2 is basically a little bit brown. In water it gives you this yellowish color. Okay, so this color is due to formation of NO2. You can mention that. Give the balanced chemical equation for the reaction. So you can balance these reactions. So you are using conc HNO3 in 2 cases and one with the diluted HNO3. So sulfur directly with conc HNO3 you can automatically write. So this will produce H2SO4, because conc HNO3 highly oxidizing. So it will make sulfur to its maximum, SO4 minus. So it should produce H2SO4 as one of the products. And then it will produce NO2. This is the oxidizing power of HNO3, because HNO3, when you have it, it will first decompose like this, forming NO2O and water, not dioxygen, actually atomic oxygen in the reaction with sulfur. Okay, so H2SO4 is formed, NO2 is formed, and additionally water is formed. So in the balance equation, you should have 2 water molecules. Okay, so try to balance these two. It will be 1 here and 6 here in front of NO2. And copper with diluted and conc, we have, I told you in our activity series, the reactions differ based on the dilute nature and concentrated nature. Okay, so when you have dilute, it will produce copper nitrate, NO plus water, and when you have concentrated, it will produce copper nitrate, NO2 and water. Okay, so try to write down these and try to balance, and you can check it even in the answer script, what are the balance coefficients if you need at the end. Okay, so this is a normal process that is related to nitric acid. Very small questions, 1 to 4, and then a little bit of theoretical behavior of nitrogen in HNO3. Right, then the remaining part of this question, environmental. So based on, again, nitrogen, major component in the earth. So you know this was 78% by volume in the atmosphere. So nitrogen, oxygen, argon, carbon dioxide. So remember this order. Okay, so nitrogen will be highest, then oxygen with 21, then argon, then carbon dioxide, then helium, then hydrogen. So this is about the gases. And in the earth crust, if you want to know the composition, it has oxygen maximum, then silicon, then we have aluminium, then we have iron, and then we have calcium. Okay, so these are the composition. Toward this direction, the composition decrease. This is in the earth crust and this is in the atmosphere. The gases, this is the elemental composition from highest to lowest in the earth crust. So special conditions are required to fix N2 due to its inert nature. Explain why N2 is inert. So you need to mention there is a triple bond between nitrogen atoms in N2 molecules. So it needs higher amount of bond dissociation energy. It has higher amount of bond dissociation energy. So it needs a lot of energy to break this. Therefore, this is highly non-spontaneous in nature and it is inert. Okay. So state 2 natural N2 fixation processes. So basically N2 is fixed by lightning. That is one natural process. And the other natural process is N2 fixation by microbial organisms. Okay, so one is lightning, the other one is microbial organisms. Right. Third one is state the name of the main industrial process that is used to fix N2. That is the Haber process. You know, we fix this into using Haber process using hydrogen to form ammonia. Identify the two nitrogen compound that contributes to photochemical smog. So you should already know at this point what are the compounds that causes this photochemical smog. It is NO and NO2. Okay, so this is NO and NO2. NO2, right? Explain how the compounds you mentioned in above contribute to photochemical smog. So here you have to write the reactions. So you can explain that NO2 in the presence of H mu, it is our light, UV light. So it will produce NO. We have already discussed this, and atomic oxygen. And this atomic oxygen can react with O2 and form our main pollutant in the photochemical smog, that is O3, right? And furthermore, this atomic oxygen also can react with water to form, what is it? Hydroxy radicals. Okay, so this will form hydroxy radicals. And all these NO2, NO, O3, and this hydroxy radical convert the airborne chemicals to produce various organic compounds. Okay, so you have to mention this. First, you have to mention these reactions happen, NO2 giving NO and oxygen, atomic oxygen, and this atomic oxygen react with O2 to form O3, and oxygen with water gives OH radicals. And all these NO2, NO, oxygen radical, O3, and OH radical react with airborne particles in the atmosphere to form various organic compounds. Okay, so that is how it forms this compound sum made. Okay. Name two nitrogen containing organic compound that contribute to photochemical smog. So you already know PAN and PBN are formed. So peroxyacetyl nitrate and peroxybenzoyl nitrate. PAN, PBN is already formed here. Okay. Name two detrimental effects that photochemical smog has on the environment. So we have already discussed. It reduces the visibility of the eye. So it reduces visibility, and even it causes toxic to plants, and even for the fabric material it causes a lot of problem because of O3. Okay, so you can write two of that. Identify the main nitrogen compound that contributes to greenhouse effect. So you know the main contribution to the greenhouse effect is N2O, which is not related to here, photochemical smog. Identify the nitrogen gas component acid rain. So again, it is NO and NO2 for acid rain. So N2 gas can be prepared in the laboratory by thermal decomposition of compounds. So give balanced chemical equation for two such reactions. So the easiest thing is ammonium decomposition. So if you remember about NH4, NO2. So normally we discuss two ammonium nitrate compounds, NH4NO2 and NH4NO3, the nitrate one and nitrite one. So when you heat this one, you know it will produce N2 gas plus water. Okay. And if you remember about ammonium nitrate, NH4NO3, it will produce N2O gas plus water. Okay, so we can write this first reaction, that is NH4NO2 giving into water. And second, if you can remember, we discussed another one, that is ammonium dichromate. Okay, NH4 Cr2 or 7, and when you heat this one, if you can remember, it will produce nitrogen, Cr2 or 3, oxide of this chromium, and water. Okay, so you can write down this reaction, but make sure to balance. Okay, so these two are main reaction that you can write in this case. Question number 10. So question number 9 is done.